Thank you very much. Good afternoon, everybody. I'm Patrick Ryan. I am a 2014 grad of AIE. I also have a Bachelor of Fine Art degree from Western Michigan University from 1995. So obviously there was a big gap between where I started and where I am now. I will walk you through kind of like a little bit about me. I also want to talk about creative process, some of the creative process we use at Microsoft. I also want to talk about portfolio, because you guys will all be at some point putting out a portfolio. And so I always want to start a presentation, and let me give you an asterisk on this. This presentation that you're about to see is actually a portfolio presentation. So I had to do this portfolio presentation just recently. I figured it was good to bring it in and share with you so that you guys could see kind of what some of the expectations are out in the field for portfolio presentations. So we can talk about that as we go along. If you have questions, interrupt me. I'm happy to answer any questions you've got. But I wanted to talk about creative process and portfolio and kind of give you guys kind of an expectation of what some of the studios look for. So I always like to start with this. This is the 5 pillars of the organization I work with right now. Create without fear, lead by doing, be curious and keep learning, tell great stories, and united we stand. The first 2 I've been doing my entire career and just didn't realize I had been doing it. It wasn't until they put these 5 pillars out and I read about them that it really hit home for me. And what I mean by create without fear is don't be afraid to fail. If you're not failing, you're not going far enough. If you take the first idea, the first iteration of whatever concept that you're working with, you haven't done all the work. You haven't failed. So keep going until you fail. Then you know where the guidelines are, and you can work within that, and that gives you a better process. Lead by doing. Just go out and do it. Don't worry about like, do I know how to do this? Have I done it before? It doesn't matter. Go out and do it. Learn it. Lead by doing. Be curious and keep learning. Again, never stop learning. I learn every day. I work with people who are amazing and brilliant, and I learn from them every single day. And if I don't know something, I go out and I do research about it, and I figure out how to do it. Tell great stories. Tell great stories is one of the through lines for all of our work. If we don't tell a great story, we won't get funding for the project. If we don't tell a great story, we won't get users to sign on to whatever it is we're building. If we don't tell great stories, we don't get buy-in that our ideas can go anywhere more than just an idea. Telling great stories is something that goes through everything, and the portfolio presentation is another instance where you want to tell a great story. You want to walk out from that interview with them knowing why they should have you on their team. And then united we stand. Like, you can't do this alone. You're always going to be with other people. You're going to be working in open air offices where you have designers and tech artists and engineers and PMs and studio leads all sitting in the same room, all working together. That's the only way you can succeed. So this is kind of like where I came from. I was a graphic designer for 23-ish years. I did print, web, photography, illustration. I did CMS programming. I did all sorts of random stuff. And then in 2012, I was working in a performing arts organization here in Bellevue that was raising money to build a performing arts center. Economy tanked, and they cut a bunch of jobs. So I basically had to make a decision. Do I stay with what I've been doing all this time, or do I go someplace else and do something new? And I thought, I'd done a lot of what I wanted to do in my career already, so why not try something new? And I always had a passion for technology and games, and I thought, if I'm ever going to do it, this is the time to do it. So I started a completely new path. I started learning ZBrush, I started learning Max and Maya, and just throwing myself into that space. And that led me to AIE, where I was able to graduate in 2014. Right after that, I landed a gig at Microsoft working with HoloLens. First part of it was as a 3D designer. So I was doing 3D modeling, I was doing some shader work, and then I kind of evolved into a tech artist. And some of the things that we did initially were things like this. This is a shader node tree for one of our buttons in Skype. Skype was a product I worked on for HoloLens. The interesting thing about the HoloLens when I first started working with it is it basically breaks everything we know about user experience. Up until this point, everything has been on a 2D screen. I look at the screen, and it doesn't matter what angle I hold the screen at, nothing changes. With HoloLens, it's immersive, so I'm able to walk around in my space, and we put holograms in your space, which means that I can be looking at the UI from any direction. I can look at it from behind, I can look at it from the side. How do we get the user to understand how to interact with our software while being able to look at it from any direction? And so this was a problem that we had to solve for user interaction. Right now you have a hover state with a mouse where I hover over a button and maybe the button color changes or something like that. We needed something similar to that, but because we can look at it from multiple directions, what is a mouse? The cursor on a HoloLens is just a cursor in the middle of your view, and when I look at something, like if I'm looking at Vic, I can see I'm looking at Vic, but how does the software let us know that it sees Vic? So one of the things that we worked on was this system of interaction. So if this is our cursor and our button, as we hover over that button, we're actually attaching a light to your vision so that you're casting a shadow across the icon and onto the background. It's this kind of user interaction that is different than the standard 2D user interactions. And this is, I mean, it's a very simple thing, but what it did was it showed us how to reinforce the 3D nature of the UI. The UI is 3D in your world anyway. We need to kind of play off of that narrative and reinforce everything that you're doing is in 3D. So that was kind of like some of the first things that I had done on HoloLens, just as a kind of a precursor to the next part of this. One of the things that I wanted to do in this talk is kind of take you through the creative process. And in portfolios, it's super important. I can't stress this enough. It is super, super, super important that you show process. We can see the end goal, the render, that's great. You know, a render is a render is a render. But until we see how you think and how you got to that render, you don't stand out from the crowd because everybody can make a render. So what I want to do is kind of take you through a case study. And this is a great way in a portfolio to kind of walk them through your process, talk about your creative process, talk about how you get from point A to point B to point C, and at the same time, for a lot of you, you're not going to have a lot of pieces in your portfolio when you go for your first jobs. This is a way to leverage that by saying, I take one piece and I can turn it into 10 minutes in a portfolio review. I don't have to just say, here's my render, this is it, this is what we did. You can actually walk them through the process, and that helps because they get to see how you think, how you act, how you collaborate with others, and what the thought process is to get you from the start of that idea, that germ of the idea, all the way to the finished product. So Binocular Scanning is one of the things that I've been working on recently, where 3D scanning is traditionally been either with technologies like LiDAR or depth sensors or photogrammetry. When we are talking about kind of where Microsoft is going, we have this initiative called 3D for Everyone. We want everybody to be able to interact with 3D content and create 3D content. But we know that there is a big barrier of entry to 3D content creation through DCC tools like Maya or Max or ZBrush or any of those. So we want the everyday person to be able to just generate 3D content or consume 3D content. One of the easiest ways to do that is through scanning. So that's a fairly innocuous statement. However, scanning is not an easy thing to do. So we have to actually create a system that allows a user to take a phone with a monocular lens, a single RGB camera, no depth sensor, no IR camera, nothing, just a simple RGB camera, and through a real-time photogrammetry solution, create a 3D model. In this study, one of the things that we narrowed in on is when I'm in the process of scanning, what do I see? How do I know how much I've scanned? How do I know if my model is complete? How do I know when I'm done and I can say, okay, process the model and give me my model? So we started with this as a problem that says, okay, we just need some system for user feedback that says this is what we've seen and this is how you know it's good, or that you can give up on the scan because we're just not going to get it. So the first thing we do is we do a ton of research. We'll go out and pull hundreds and hundreds of images and just try and find kind of a through line of like, what is it we're trying to solve? And so in this one, we started to look at data visualization. Basically what we're doing is we're taking a real world object and turning it into data. So one of the first places we looked was data visualization. How do you take complex data and represent it to a user? We then started looking at things like surface. What does a surface say about an object? Because as you're turning a surface into a digital object, how can we leverage what the surface looks like to give the user some feedback? Next, we looked at resonance and collision. Like if you take a stone and throw it in water, the water rings ripple out and it will actually hit the sides of the pool or the other rock in the stream or whatever it is. How does that resonance, how does that collision, how can we use that to inform what the user is doing? We also looked at surface geometry. Like one of the things that we all know as 3D artists is, we need geometry to make up the surface. Is it something we can easily explain to a user who doesn't understand what a triangle is used for? And the last one was waves. How we can wash over an object. If you think of snow falling onto an object, or radar or something like that pings back a shape. These are all the things we started to look at as possibilities for exploration. Once we've done this initial exploration, we've got some initial concepts. What we want to do is we want to set out guidelines for success. And this is something that every creative process should have early on. Like, once you know kind of what the inspiration is, you have to give yourself guidelines so that you stay on target. It also helps you to fail ideas quickly. So basically what you do is you set up a system of what we call filter criteria. So I know a goal is our user needs to be able to understand what they've scanned. And so we start coming up with a storyboard like this, where we'll have a hero image and then we'll set out our experience goals and outcomes, and we'll talk about exactly what's happening in each step of the way. This is still early in the process. We haven't built anything. This is all sketches, Photoshop comps. We will farm this content around with all people of our team, people of other teams, to see if it makes sense. So basically what we're saying here is we have a camera feed. We are showing an object in the real world, and what we want the user to be able to do at this stage alone is just to frame up the image that they're going to scan. We're darkening what's outside because we have to give the user affordance to understand if I start too close to the object, I might not be able to scan all of it because I have to understand how that object that I don't see correlates to the object that I do see. The next thing we do is we start talking about the affordances of how do we give visual feedback over a camera feed. This is something that, as you're looking through the camera, you're going to end up with noise from the object, noise from the background, but we also have to put noise over the top of it to show you what you've scanned. And so we started looking at things like how can we pulse information across a screen, but also adding an affordance so that we're darkening the camera feed at the same time. What is the artifact we leave behind? Right now we're talking about some sort of mesh that scales across the screen. We also have to understand, like, once we add that visual feedback on top of the camera feed, how does the user understand what they're seeing? Is it too noisy? How do we dim down the camera feed but allow you to still see it? And then finally, we can't obscure the object completely, because as you're going around to a side that you haven't scanned yet, we haven't generated any mesh for it, we don't know what's there. So we keep going through these processes and say, okay, now we've gone to another side. Now how do we understand the next part of the phase? And we wash over it again, and as we're washing over it, we leave more mesh behind until we've got a complete mesh. So this is kind of like the start of the process. But this also really highlighted a lot of problems for us. So one of the problems we found out early on was that the tech and power constraints of phone is never going to allow us real-time meshing, which is great. How do we do this now? The experience goals and outcomes still stay the same, but now we have to come up with a different visualization. So then we go back to looking for inspiration again. So again, we go back to how can we use something that is not mesh to look like an object? And so we're looking at all of these different objects made up of smaller objects. We start looking at how we can use light, how we can use things that are not real objects to represent another object. And then this last one is kind of a, this is the set that we ended up using as the basis for our new story. And our new story was light. So how can we use light to describe a surface? And so like whether we're splattering light and color on the surface, or you have this remnant of light on what was there for the spider web, we just want to use this as our new metaphor. And then we start going into prototype. So this is a quick prototype that I had done where I'm given a depth image, and basically it's a set of data for positions per pixel on the image. So we know for every pixel in the image, it is this far away from the camera lens. When I throw that into Unity and say, okay, build this thing, we realize really quickly that understanding what you're seeing is super hard when you're looking at that angle. Even off angle, this is actually, who can understand what this is? Is it a person? What do you think it is? A Hulk? Sphere in a plane. Closest. It's actually a skull sitting on a what's called a tracker board. So obviously that doesn't look anything like a skull. And understanding what particle is closer to you and what particle is farther away from you, super hard to do. So then we started going back to our inspiration and saying, okay, what can we use from this inspiration? These images where we can help to understand distance when you're looking at it from a specific angle. And one of the things that you can see here is we have things out of focus here and in focus here, out of focus here and in focus here. Why don't we use depth of field? So when we go back to this and start adding in depth of field, it's a little bit more clear. This one happens to be an apple sitting on a table. Looking for a skull, yeah. And then we start adding more information. So now we start adding color. So now we have depth of field and we have color based on direction to help you understand the volume of what you're seeing. And this is a prototype that was demonstrating this whole system. And this is actually a system that I got a patent for because nobody had done it this way yet. But basically, we're doing this all in one pass. There's no second render for depth of field at all, which means that super cheap on the phone, super fast. But it also gives us the ability to not only understand what's in focus, but we can leverage old behaviors from users understanding how to use a camera. If you move closer to something, it goes in focus, or you move away from something, it goes out of focus. So what it actually does is it helps you keep an ideal distance from the object. That helps us with reconstruction. So some of these systems we're building in for technical reasons, but we're trying to shape user behavior based on the feedback. And then we start looking at motion. It's one thing to say, okay, we've got a bunch of particles sitting there, static. What is this motion? How do they coalesce around the object? Is it this cloud of particles which kind of swirling around and then start landing on the surface? Is it something else entirely? So these are some of the iterations that we go through. And then this last part is, this is a full prototype that I built of an end-to-end experience using the phone, so that we can use this as a target for user research. To go ahead and capture, to build a tech, to do this, to then bring it to a user to say, does this make sense? Too expensive. So what we're doing here is I'm building an experience that is fake. We're not actually scanning something. But I am making it look as though you're scanning something. You can move around. It uses the IMU of the phone. It will lay down particles where you see it, and then give you a final build of a model. And what we can do with this is we can take this down to user research and put it in the hands of users and ask them questions like, what do you think is happening here? Does it make sense to you? Where do you want to go next? What do you think is happening now? And then as they answer those questions, we can understand, are we actually getting them what we think we're getting them, or are they lost? And then we can go back and reevaluate. And so doing it this way, where it's lo-fi, we can prototype this stuff out. We don't have to worry about spending a lot of time developing these systems to work for real, and then we get our user feedback so that we can then go off and say, yes, this is going on the right path, or no, we have to alter our path a little bit so that by the time engineering is ready to come through and implement, we know exactly what we need to make. The next part of this is, once we started saying, okay, well, we understand kind of what's going on here, one of the things we were missing is we needed to understand the blue light particles were one thing, but it wasn't really describing what people were seeing. And so what we started doing is saying, how can we bring the RGB color from the world into these particles? And to do that, I actually had to build another tool to help fake it. And that's what this tool is doing. Basically, you see there's a camera going around here. It's taking an RGB image and a depth image at the same time in Unity. And I'm actually storing the normal, the color, and the depth into a CSV file that we can load into that original prototype. And so now I can take any 3D model and turn it into a point cloud, which we can then load into the initial prototype and then hand that off to somebody else. So we could do a demo to somebody, and we can quickly change out what our model is. But then this tool also allows me to do things like, right now I'm showing a certain size of particle and a certain density of particle. What if I don't want that size of particle? We can then go in and change and update the particle and say, what size do we want it? Or I can say, that's too dense, let's do it again, but we're using a smaller image. And so you'll see there are a lot fewer normals being pulled in there. And in the end, we can understand from an art perspective, what does this look like? How do we get to that final representation without costing us a lot of time engineering and then re-engineering and re-engineering? So we're looking for the fastest way to fail these ideas. After this is basically what the prototype would look like once we've decided on particle size, on density. We've taken this model and I've done a camera track in Match Mover. So I took a video of this object and then Match moved it so I can attach it to the camera in Unity. Now we get something that looks like a person is actually using the image. So that we can use this to show to either like a CVP that's we're trying to get more funding from, or we're trying to just show progress. That we do a lot of this kind of work so that you can understand, hey, this is where the visual is going, this is where our targets are, but then we can also use this to help sell the ideas inside. And then this is where we would take a frame and then overlay that feedback so that you can actually see this is what the thing should look like. This is the target. So then we can take this, give it to the engineers, and the engineers have everything they need. They can say, oh, we see at this point, the feed darkens out. We've got the particles are world locked. We understand what it looks like, and it becomes a good art target. And then beyond that, we have to start thinking about things like, okay, well, that's one part of it. The next step would be, what does the reveal look like? Okay, we've got these particles, and we end up returning a mesh to you. What does that look like? So we start thinking about, like, is there some sort of progression system where we start with a very simple sphere, and then that changes into a wireframe mesh, which changes into a low fidelity colored mesh, which changes into the final high fidelity mesh? Or, do we go some other way where we start with a voxelized model? And this is a prototype I built where I was voxelizing models so we could quickly say, I need a voxelized model that's 100 by 100 by 100 or 50 by 50 by 50, and we just run it through and allows us to quickly iterate and say, yep, nope, this is good, this is not good, and keep the velocity up. So now, and I mentioned this earlier, what I work on now is the 3D for Everyone initiative. And anybody here on Windows 10? Anybody here used an application called Mixed Reality Viewer-ish? So that's basically the first part of this initiative. Microsoft understands that with the advent of HoloLens and AR and VR, people need to consume in 3D. And to consume in 3D, you have to be able to open up a 3D format. So part of the initiative is settling on a format that everybody's going to use so that we can share content, so that you can open the content, so that you can share it to Facebook or share it to Instagram or whatever. So part of it is we work on a format called GLTF, which is a real-time streaming format. It's open source, but Microsoft has a big presence on the committee for ratifying the new content. We also work with a web service called Babylon.js. So what Babylon.js is actually really good for is it's a JavaScript library, allows you to use TypeScript or JavaScript and implement the library, and you can do things like, I want a 3D render on my website, and we can do it in 2 lines of code. So that's another initiative. We've got the Mixed Reality Viewer, which allows you to open up any FBX OBJ right on your desktop. We've noticed ever since we released that, we had a lot of game industry people really adopt that as part of their dev flow, because they don't have to go to the artist to open an FBX anymore. They can just open it right there on their desktop. It's great. But in doing all of this stuff, there's a lot of tech support that has to happen. So, for example, this is a model that I had to create, and yeah, it's a super complicated model, obviously. But the reason behind this model is we had to understand we're using a GLTF format that wants a metal rough PBR rendering model. Okay? We had to explain to the engineers, this is what you're going to get. Here's a model. Here are the textures that make up this model, and we also wanted to understand easily by looking at the texture what you're looking at. So I had to come up with a model that we could look at a texture, any one of the textures, and understand, okay, well, this is part of the bottle, and this is part of the cap, and this is part of the sleeve, and here's the little LED part of the sleeve. And so we'll do things like this. Or one of the crazier requests that I got recently was, hey, we need a model so that people can test the renderers that has metal, wood, leather, glass, and plastic in it. Oh, and it has to be a real-world thing. It can't be a fantasy thing, because people have to be able to look up real-world reference to this and understand what it looks like, so when they put it in their renderer, they understand, yeah, that's what it's supposed to look like. So this is a World War II helmet that I had to build and texture in PBR, so that they can take it into their renderer and say, yep, that looks like wood, that looks like plastic, that looks like glass, that looks like leather. and then they get one test case. So that we release this out into the open source community, and people who are implementing Babylon.js can take this model and go, yep, this is what the render is supposed to look like. Here's the model. Yep, my render looks the same. I've done a good implementation. And this is where the presentation gets a little meta, because this is another part that I helped concept. I was on the initial team that did the concept for this as well as the initial prototypes, but the actual implementation was done by the Office team. So it's meta because the piece here is PowerPoint itself. So that animation is actually a 3D object moving in PowerPoint. There is no animation, there's no images, it's just a 3D model that we brought into PowerPoint. We set on a slide, this is the rotation, and then you go to the next slide and say, well, this is where the position, this is the rotation, and then you say, okay, then morph between them as I advance my slide. So this is actually an implementation of 3D for Everyone that we worked on. So it's available in Office right now. You can use it in Office, you can use it in Outlook, you can use it in Word. Basically, all the Office products allow you to bring in 3D models now. So, and then this is one of the other things that I get called on a lot to do, which is Paint 3D is the new free Microsoft Paint offering. It allows you to build in 3D. So you can build with primitives, you can sketch and extrude, you can paint right on the surface, you can bring a model in and paint right on the surface of it. Does all the UVs for you, and will export into FBX, GLTF, GLB, all of those formats. But one of the things that they ask us to do is, as an artist community, they want us to go out and show what Paint can do. So we'll go out and build models. This was one of the desktops that was put out for Halloween, so that it was all content created in Paint, sent out so that we are evangelizing our own product and showing people what the product can do. And the last thing I'm going to leave you with is this idea that nothing is precious. This is something that I remind myself of every day. Nothing is precious. And what I mean by that is don't ever get locked into an idea, because as soon as you get locked into that idea, you've lost the fight. If you're working on a model and you can't get the face right, and you think, the nose is just wrong, but I spent all that time modeling the nose, I don't want to redo it, you've lost. You have to just start over. Like, it's not precious. Yes, you put time into it, but trying to work around a problem to save the time you invested will cost you more time down the line. So this is a sketch that I had done, and this was initially started as a 20-minute sketch. I went into this, and I used to do this on the ferry ride back and forth at home every night. I'd have 25 minutes, I'd sit down and I'd do a portion of a sketch, and the next day maybe I'd do a new one, or maybe I'd start, continue on the old one. So this is basically three and a half 25-minute sessions. But what I had done is I went in saying, okay, I'm going to make some orc, ogre kind of creature, right? Thought it was first going to be just a head, and it ended up being an entire creature. But I spent a bunch of time working and reworking the face, so that the face that you start seeing is not the face that we end up with. And you'll find that as I work, I'm constantly working on an area, and then I'll go work on something else, and I'll come back and work on an area, and I'll go work on something else. And every time I come back to it, I might change it completely. I might just smooth out the whole thing and start over. Because what I'm trying to do is say, what is the sculpt telling me to do? Where is the concept going? Is it exactly what I want it to be? Is it not what I want it to be? At this point, I'm like, yeah, that face isn't right, but I don't know what it is because I don't want to know what the rest of the body looks like. So I started building the rest of the body. I decided I don't want it to be a six-pack creature. I want it to have some weight to it. But then, what is the weight? And does the form make sense with the face? Does the form make sense with the overall stance? And which is why I kept building out more and more of this creature, because I wasn't sure what I wanted to do with it. If I decided, I spent all this time making this head, and made the body to match, I wouldn't have ended up with the sculpt that I ended up with, because I would have limited myself based on that initial concept, which was faulty. You know, at this point, I've probably already smoothed it out at least once. At this point, I know the stance is wrong. I know the weight is off, and I started making some big changes at this point. So now, you know, everything's off. All the sculpting I already done. Don't care. Nothing's precious. Keep moving. I realized, yeah, the balance is off on the character. It needs to be more top heavy. So how do I make it more top heavy? I started adding more meat to the shoulders and the back. Slimmed out the waist a little bit. Basically, keep going and going and going, and I'll skip to the end here. This is basically from the top left to the lower right, how many times I redid the face until I ended up at the lower right. That is one of those things that unlocks you as an artist, like continually reevaluating what you've done, understanding where you need to go, not being afraid to start over or trash something that's not working. Eventually you will get where you need to go. And you know, again, it goes back to the create without fear, lead by doing. That is the best thing I can leave you with. So thank you for your time.